Good morning, ladies and gentlemen, and welcome to our today's webinar. Today we speak about 1500 PV modules and the deployment in practice. And we will answer the question when to switch from 1000 volt to 1500 volt. And my name is Stefan Ringbeck. I'm Product Marketing Manager here at Trina Solar. The webinar will take approximately 20 minutes and then additionally questions. If you have questions, please put it in the question pane or in the chat. And after the presentation, I will go through the question pane and chat pane to answer all your questions. And additionally, after the webinar, because the webinar will be recorded, we will share the recording and the presentation with you. Thank you very much and enjoy our webinar. First of all, because we're speaking about system design today and want to see when it makes sense to use 1500 volts and what are modules and what are the advantages and when to switch from 1000 volt to 1500 volt, we will discuss today's several locations with different climates to see what is the impact and what are the differences for each single locations. We are speaking about the locations I selected are here placed in Europe. One is in Ireland, in Malin Head, at a very foreign or very north location, then Lisbon in Portugal, Munich here in Germany, and Kiev in the Ukraine. I selected locations with a high variety of climates to see how the climate and especially the ambient temperature is impacting the system design. First of all, what you can see here is the ambient temperatures at different locations. Here I used as a source Wikipedia, who had, let's say, recorded average temperatures and as well the average low and record low temperature. And if you're comparing the 4 different locations, you can directly see that there are quite big differences. So if you're looking to Germany, also to Munich in Germany, you see that the ambient temperature can go down to minus 25.4 degrees. In comparison to Lisbon, what is close to the Atlantic and more south, the record low ever was at minus 1.2 degrees. If we go to the Ukraine, we are directly at minus 33 degrees or close to minus 33 degrees. And then Ireland with Malin Head at minus 6.7 degrees. You can already see that there's a quite high difference between the single locations, and today we will see what is the impact on the system design. For this study, I assume that the module temperature is approximately 3 degrees warmer than the lowest ambient temperature. Because I assume that during the day the temperature is slightly higher than at night, but I also assume that we have the system running on a very cloudy day, a very dark day, where it's really cold during the day, and then the clothes are, let's say, get cracked and the sun is coming out directly, and you have a certain amount or certain level of irradiation, which means you also have directly jump on a very high voltage level. Further, I used an inverter. Here in this case, it's a Kako inverter, what is able to have a system voltage of up to 1100 volts. And for sure, since this is completely individual, this depends for sure on the information what you have on the climate, the ambient temperatures, and the irradiation. Therefore, it's really location dependent. Overall, I compare this analysis with, for example, the design of a heating system. For example, here in Germany, we have several different references which needs to be used for sizing a heating system and to achieve a minimum room temperature, and this is also depending from the region. And the similar can be used or also transferred in for PV. And for PV, it's important that you have a proper designed system to, first of all, don't exceed certifications and limits, to have a safe and proper running system, and also to have a most cost-efficient system, which I will speak about. The cost advantage. In general, it's let's say it's really important to be within the standards, or also to assume the VOC, since you always have to do maintenance, and especially if you plan your regular maintenance, it's not a bad idea to go to a time during the year where you usually have a low energy production, to have a low impact on the energy production due to downtime. And therefore, for example, winter time is perfect time, because you usually have cloudy days, especially here in Central Europe. You have a very low level of irradiation and a low energy production, but you can have cold temperatures, and you can have suddenly, let's say that clouds are getting cracked by the sun, and the sun comes through, and that you have then a certain amount of irradiation, even at quite high levels, and then you directly have a jump in the voltage. And this will be shown in the webinar today, what is the impact on the different locations. Here we speak about the inverter. The inverter has here an MPP range from 580 volts up to 900 volts, and the absolute maximum, the VOC, the system voltage for the inverter, is 1100 volt. What is also getting important for the further analysis. Here I'm comparing first what is the impact if I take 1000 volt modules. If I take 1000 volt modules, and if I go to Munich in Germany, you can directly see that the string length is here with designed with PVSys, what I used for the whole presentation and whole simulation. I did the maximum string length here is 22 modules without exceeding the system voltage at the assumed minus 20 degrees, what is approximately 3 degrees higher than the ambient temperature shown before. But if I compare it with Lissabon, what has what has a higher minimum ambient temperature, you can see that the string length is 24 modules compared to 22 modules, which is already significantly higher. But you also can see from the inverter utilization that the VOC voltage is only below 1000 volt instead of below 1100 volt, or close to 1100 volt, because the models are only certified to up to 1000 volts, and it needs to be avoided to exceed the 1000 volt certifications. I mean, even if there are certain let's say safety margins in, and the material is also selected to let's say to be able to get the certification for 1000 volt, it doesn't mean that you can exceed it, especially if you want to follow the technical rules, what I said here with the IC with 1000 volt. If you now take a look on the Ukraine, on Kiev, here you can see that there the string length is also 22, and if you look to Ireland, to Malinehead, it's 23 modules within one string. Now we take a look on Munich and comparing what happened if you use 1000 volt modules, but we want to utilize the maximum string length. What is suggested from PVSys. You can see that if I select on the left hand side, I've selected 22. I have a system voltage of in the open circuit conditions of 977 volts, and if I compare if I go then to 24 modules, so to the maximum string length, what I can select here in PVSys, I go with the VOC up to 1066 volts, which means at minus 22 degrees I exceed the certifications of the modules, and I exceed the certified maximum system voltage, which means I can reduce the string length, or if I go with the string, I may have trouble if something happening. For example, if people have to do maintenance during the winter time, there's a risk of an electrical shock, because, for example, the inverters are offline, or if the inverters have something or taken off the red, you always have the system running in VOC conditions. That means if something happened, then you need to make sure that you're within the certifications. Now, what happened if I switch to 1500 volt module? So it's exactly the same type, it's the same polycrystalline module with the same power range. The only difference is that it has a different certification. The 1500 volt module is certified for system voltages up to 1500 volt. If I now take a look on the string design, you can directly see that this already switched from before it was from Munich from 22 to 24. Now it's from 22 to 27. You can see it here on the left-hand side. And if I want to be below the 1100 volt, what is the limit of the inverter, you can see that I can select 24, and I already have 2 modules more per string than in the case before. If I go to Lissabon, I go from 24 up to 26 modules, which is also an increase of 2 modules per string, and a better utilization of the inverter. If I go to Kiev, it's also 2 modules more per string, so I go from 22 to 24. And if I look on Marlin Head, due to the, let's say, temperature, you can expect you have here the biggest advantage, because you can go from 23 up to 26. That means you have 3 modules in addition per string. So depending on how you want to advertise, for example, the DC generator on the inverter, and in general, it's better to have a longer string to have to operate on a high voltage, to operate on the best efficiency level, and also in terms of cost, to have the system voltage utilized at its best, to have the lowest investment costs. If I go on the table, and if I'm comparing all the 3 different locations, here in this table you can see a comparison of the single locations with the inverter setting of 1100 volts. The ambient temperature is here selected, and then I calculated or show the string length, the VOC, and the inverter utilization. If you now take, for example, Marlin Head, you can see that the lowest ambient temperature is minus 6.7 degrees. The string length with a module what is certified for 1000 volts, it's set to 23, what means the inverter utilization is 88%. If you take a look for modules which are certified to up to 1500 volt, you can see that the string length is increasing to 26 according to the previous system design, and the inverter utilization goes up to 99%. If you, for example, take another example, let's take Lissabon. And Lissabon has an ambient temperature of minus 1.2 degrees. The string length for 1000 volt module is 24. The inverter utilization is 90%, but you're already quite close to the 1000 volt limit of the modules. But if you go to the 1500 volt modules, you can utilize the inverter 89% with a string length of 26. That means if I take this, you can have a better inverter utilization in terms of maximum string length. If you switch the modules from 1000 volt modules to 1500 modules, and the increase of the utilization will be between 8 and 11% depending on your locations. Now, one of the questions is, what are the savings? In this example, I took a look on Marlin Head in Ireland. I used still the inverter with a system voltage of 1100 volts. I used for this comparison, since I don't want to have it impacted with different module prices, I simply used the same modules for all and placed it for under different rules. That means the first case, what is here marked with 100%, is in a 1000 volt certified case. The middle one is a module certification with 1500 volts, and the third one in each diagram on the right hand side, it's then if you go directly to a 1500 volt system. And for sure, the calculation and the savings are highly depending on the inverter and its location, what kind of configuration you can take based on the different climates, and for sure on the maximum system voltage what can be applied or the inverter is certified for. If you now take here the look on the Marlin Head in Ireland, you can directly see that in the first case, if I go have a maximum module certification of 1000 volt, the IC 1000, we have seen that we have a string length of 23 modules. So if you now go with a 1500 volt module, the same inverter, I can increase the string length to 26. That's here shown in the middle. And you directly have a reduction on the electrical components and electrical installation of 11.5%. The 11 of the electrical components are the cabling, the string cables, for example, the combiner boxes, air module interconnections, and so on and so on. To achieve the best LCOE and the lowest system cost, it's always the best. LCOE is levelized cost of energy. For this, to achieve the best values, it's always to have low system price, a low BS cost and price. That means you have to optimize the system, and an optimized system means that you have to do low installation work, which means you have to reduce the installation as much as possible, and the installation can be reduced by, for example, using the maximum string lengths. If you now go from a pure electrical level on a system level, because at the end the system is a watts count. Here in this example I have system cost of assumed slightly above 90 cents per watt peak, euro cents per watt, 90 euro cents per watt peak. And if I go from a 1000 volt module to a 1500 volt module with the increased string lengths, you can see that the savings that I have on the electrical BS with 11.5% are leading to a system price reduction of up to minus 1.9%, which is already, let's say, a good reduction, because you can utilize the capabilities full, and it's already a certain saving, especially under the very price driven and price pressure we have here in the solar industry. If you now compare it with a 1500 volt system, that means we also have an inverter what is capable of 1500 volt. The string length is increasing to 35 compared with in the beginning 23. That means on an electrical BS, on the electrical BS components, the savings in this case are 34.3%, so approximately 1/3 what is coming due to the increased voltage from 1000 to 1500 volt, what is also means 1/3 less connections, and this leads to an overall system saving of 5.7%. That means already for a system where you have inverters with 1100 volts, you can save already on the system level with 1500 volt modules. For sure, this is also depending on the single component prices, but here it's a pure saving due to less components and less installation work. Here, a short summary. In general, if you're having systems or modules that are certified up to 1000 volts, you only can use it for systems where you have a maximum voltage of 1000 volt. If you have modules with 1500 volts, for sure you can use it in systems with 1000 volt, 1100 volts, 1200 volts, or even 1500 volts. Without the end, the 1500 volt modules is more flexible and can be used for the actual system designs and inverters and components which are on the market. For example, we also know it from the cables. There was a change in terms of standardization for the cables here in Europe, and according to the new standards, all cables for PV applications are certified for 1500 volts. In the past, it was also 1000 volt and 1500 volt. That means if you have a system with 900 volts, you always can use a 1500 volt cable. If you have a system or a voltage level on a cable of, let's say, 1020 volts, you have to use the 1500 volt cable. That means the 1500 volt cable can be used in any case, but the 1000 volt not in all cases. The same applies for modules to be within the standardizations. We also have here, I mean, that's let's say very special, but it's also a good example, especially if you're in Germany. I took here the tire example. Though if you have a car where the maximum velocity is 220 kilometers per hour and you're buying winter tires, you can have it in different certain certifications. If you buy tires which are certified for 160 kilometers, or you can select a better one which are certified for 240 kilometers. So if you're driving here on the German highway and you have a car that is going 220, and if you have winter tires which are only certified to 160 and you exceed the 160 kilometers per hour, and you have trouble with the tire or one tire explodes, you can't go to the tire company and say, hey, my tires exploded, and because they will come back and say, yeah, you drove faster than it was certified for. But if you have the tire on, what is certified for speeds up to 240 kilometers. You can use the complete capabilities of your cars, and even if something happened, you can say the tire was better than the limit of the car. Though why does the tire explode, or why had damage on the tire? So there you can go back to the company. And the same applies, for example, to all the PV applications, especially if you're on the edge. For example, you want to utilize your inverters better, you might get also allowance from the inverter company to increase the system voltage. But for the components, then it's required to use a certified one. With 1500 volt module, it's the same like for the tire. You can run it or use it for systems with a voltage of 600 volt, 1000 volt, 1100 volt, 1200 volt, or even 1500 volt. But with modules which are certified to only 1000 volt, you are limited at 1000 volts. Which means the module with 1500 volts gives you much more flexibility in terms of system design, and also ensures that your system is safe and best equipped, independent from the inverter you select, independent on your settings, as long as you're within the 1500 volts. That's already all. Though I want to say already thank you. I will now go on the question pane and chat to see your questions. Okay. Okay, the first question is there any requirement for connecting to the grid with 1500 volt PV modules? Connecting to the grid is always depending on the inverter, though. The inverter and the grid connection points are defining the limits, and if you have, let's say, in general, it's better to feed in on higher voltages, and it's even, for example, if you have step-up transformers, it's always better to go into the step-up transformer if you have, for example, a medium voltage connection. It's better to go into the step-up transformer with higher input voltage, and therefore 1500 volt systems, or in general inverters with a higher system voltage, allows higher output voltage, and that's beneficial for especially utility scale projects. But they also can be used, for example, in industrial applications where you have, for example, already AC distribution of instead of 400 volt with 690 volts, because with 1500 volt inverters you can also set the output voltage to more than 400 volts. For other inverters it's usually limited to 3-phase 400 volts, but with 1500 volt you can go up, as far as I remember, but that's for sure depending on the inverter, to up to 690 volts. Here's the question: please define inverter utilization. In this case, I use inverter utilization in terms of string lengths. I mean, inverter utilization could be in terms of the DC-AC ratio, what can be set as an oversizing or an undersizing of the inverter. But in this case, the inverter utilization means in terms of string lengths. That means the inverter, or each inverter has each individual MPP range and system voltage, and I can utilize this bandwidth with the different modules. And if we go with longer strings, I have here better utilization. That means in this presentation, inverter utilization is related to the string design, to the string configuration, and to the MPP range and system voltage. That means I utilize the system voltage. In this case, it was 1100 volt at its best. Here's a question about the inverter companies which having products in the portfolio exceeding the 1000 volt. I took Kako as example because it's one of the companies who have, for example, 1100 volts, but the further one, for example, also if I remember right, SunGrow, or even SMA or other ones are offering 1100 volts, and the number of inverters who are offering 1100 volts is, let's say, there's already a number in terms of string inverters and even central inverters. And it's maybe even higher than, for example, the availability of 1500 volt inverters, especially if we look on the string inverter size. So there's a certain number of different brands. I selected simply one, what I can use in this case as to do the case study. There's another question. The question is, as I said, in the industry, it's very competitive. Are the EPC companies installer ready in terms of training and knowledge to implement the 1500 volt and combine the savings in, for example, PERC and double phase module? I guess it depends a little bit on the region, and for example, the discussion about 1500 volt here in Europe is already ongoing since 2012. A bigger discussion, it's more implemented, let's say, in from what I know, in North America, Latin America, and other regions of the world. But even here, the 1500 volt systems are rising. I would say it depends on the case, and it also depends on the company and if they want to go new ways or if they want to stay in the common way they know. In case of other products, I guess that also some companies also want to wait to get more field data, since the products are currently under testing and evaluating, and they want to have it, let's say, shown that there's a clear benefit. From my perspective, it depends always on the case, what you're looking for in general, what is the best offer, and at the end, it's always a game between capex, that means investment, OPEX, operation, maintenance, effort, and cost, and then the energy yield, the energy production you have with the system. And at least you have to find a complete optimum. And that means, for example, you have to take a look on the utilization and then on the product, what you can use at the best. That's a question about the 1500 volt. The 1500 volt in general, in, let's say, most European countries and even in most countries around the globe, there's a so-called low voltage directive. And in most of the countries, the low voltage directive is defining low voltage below 1500 volt. That means as long as you're below the 1500 volt or up to 1500 volt, you can work according to the low voltage directive. And if you're exceeding this, then you have to go to medium voltage, which is adding additional requirements. If you want to have price information about the price difference between 1500 volt modules and 1000 volt modules, please contact our sales department. They are happy to answer these questions. There's a question about the module of the product offering. In general, so far we are offering both the 1000 volt and 1500 volt products. The only difference is if you're looking on glass modules. Glass modules always came with the certifications of up to 1500 volt modules, though there's no separate lane for 1000 volt products. And for example, also if you take a look on the connectors, the TS4 connectors, what are getting at the right now introduced in the market, they also came only in a certification up to 1500 volts. So there's only, for example, if you're sorting the connectors from us, there's, let's say, no restrictions as long as you're below the 1500 volts, and it makes it also easy in terms of procurement and handling. Okay, I've seen that were all the questions. I want to say thank you very much for your attention. If you have further questions, please write me an email. My email address is stefan.ringbeck@trinasolar.com. After it, in the next coming days, we will distribute as a recording and the presentation. Have a nice day. Thank you very much.